The Milky Way is a tremendous structure in space containing billions of stars and trillions of planets. In their turn, these objects are surrounded by gigantic clouds of interstellar dust and scorching hot gas streams. All these components make up the bizarre and fascinating picture called galaxy. And today, we invite you on an exciting journey across it.
Distinction. The sky is that giant enveloping space above our heads, sometimes blue, sometimes gray, sometimes a bit of both. Space is that unfathomably large, black, and empty, space that surrounds our planet and reaches into the vast expanse. And we all know that if you shoot into the sky high enough, you will eventually reach space. But where's the boundary? Where's the defining place that signals your departure from Earth and entry into outer space? Well, we don't really conclusively know, as there's no single place that declares your official exit out of Earth. It's not like there's a border crossing in the sky. The further up you go, the thinner the atmosphere becomes. Ask any mountain climber and they'll concur. But at even greater heights, as the atmosphere becomes less dense, outer space slowly begins to intrude, and before you know it, you're technically, if not officially, in the final frontier. So entry into outer space is more of a gradual ascent than a switch being flipped. In fact, both the UN and the US State Department don't believe in making any one area an official designation of entry, as the process is so gradual and slow that there can be no clear indication of when it is. But we know what you're thinking. Surely there must be an altitude which is generally considered space. And you'd be right. It's called the Kármán line, and it's 100 kilometers above sea level. This area was named after the physicist Theodor von Kármán, who determined that regular flight is impossible at this height. According to his studies, the atmosphere becomes so thin at this point that a craft would need to fly faster than the Earth's orbit to generate enough lift to fly. At this height, the speed required is the same as what's required for escape velocity. Therefore, the craft no longer follows Earth's curvature and is in outer space. The Kármán line has been officially designated as the point of Earth's exit by the Fédération Aéronautique Internationale, or the World Air Sports Federation. According to them, once you reach the Kármán line 100 kilometers above Earth, you are definitely in outer space and may be appropriately designated as an astronaut. However, even this boundary is questionable and not universally agreed upon. For example, the United States Air Force categorizes someone as an astronaut if they travel just 80 kilometers above sea level. This area signals the beginning of the thermosphere, where temperatures dramatically shift due to the absorption of X-rays, UV, and solar radiation. According to this particular logic, if the atmosphere is thin enough to be heated by the effects of outer space, then it's officially an area belonging to outer space. Which makes some sense, right? Others agree that outer space starts at a location just above the Kármán line, roughly 118 kilometers above sea level, so 18 kilometers further from ground than the Kármán line. This is where solar radiation and ions become abundant, taking over the Earth's atmosphere. A 2009 study conducted by the University of Calgary determined that charged particles travel at an astounding 1,000 kilometers per hour at this altitude. But even this location doesn't signal the actual end of Earth's atmosphere. Many people likely consider the International Space Station to be in outer space. It's right there in the name, after all. But even it still feels Earth's atmospheric effects. Despite maintaining an altitude of 330 to 435 kilometers, there are enough particles and molecules around it to cause drag. Given enough time, the particles would be strong enough to bring the ISS back down to Earth. To counter this, the space station accelerates with regular rocket boosts, so we can see that even our more conventional understandings of outer space are still influenced by Earth's atmosphere. You could perhaps argue that the space station isn't officially an interplanetary space, as it still feels the effects of its nearest celestial body. Above the thermosphere is the exosphere, and it's here that our atmosphere finally merges with outer space. At this level, various gases are present, including helium and carbon dioxide, but the particles are spread very far apart. However, they are still gravitationally bound to Earth. The beginning of the exosphere, officially known as the exobase or the thermopause, begins anywhere from 500 to 1,000 kilometers above the Earth's surface, significantly higher than the International Space Station. At this level, the barometric formula no longer applies, and temperatures remain constant, i.e. the freezing temperatures of space. The exosphere accounts for that distinct luminous ring that seemingly acts as a barrier between Earth and space. This ring is called the geocorona, and it can be seen in various satellite imagery. The geocorona extends roughly 10,000 kilometers above Earth's surface, but even though it seems to end, it doesn't. As you travel further into space, roughly half the distance to the moon, the sun's radiation puts so much pressure on hydrogen particles that it finally exceeds the Earth's gravitational pull. Therefore, we could claim that it's here that you're officially in interplanetary space, as Earth's gravitational pull no longer affects atmospheric particles. In other words, there's no more atmosphere. As the distance from Earth to the moon is 384,000 kilometers and solar radiation affects hydrogen up to roughly half that distance, we can reliably estimate that the exosphere officially ends somewhere around 190,000 kilometers above sea level. While you might have called a cutoff point far earlier at any one of the high-altitude pit stops along the way, this feels like the final call. So if you've made it this far, then the sky finally ends and interplanetary space begins when you're halfway to the moon. But as we've repeatedly seen, the answer to this question depends on what your definition of outer space is. According to the US Air Force, you're officially in outer space at just 80 kilometers above sea level, when the temperature begins to rise due to the absorption of solar radiation. Not much higher than this, at 100 kilometers, is the Kármán line, where regular flight is no longer possible due to the lack of density in the atmosphere. A little further up, at 118 kilometers, is where ions begin to dominate Earth's atmosphere and travel at incredible speeds. Yet even the International Space Station, orbiting roughly 400 kilometers above us, still feels the effects of Earth's atmosphere, which depending upon your definition could mean it's still in the sky. Between 500 and 1,000 kilometers above us is the beginning of the exosphere, which extends halfway to the moon. And as solar radiation overcomes the power of Earth's gravity, it's here that Earth's atmosphere officially ends and the sky's limits are finally reached.
I am the soil. I am in the hills and in the valleys, the farms, the orchards. Without me, humans could not exist. But you treat me like dirt. Do you realize that I am just a thin skin on this planet? And that I'm actually alive? Full of organisms that grow your food. But I am broken, aching, overused, sick because of you. You have withered me away to less than half of what I used to be just over 100 years ago. Are you paying attention? I am turning to dust. So maybe you could treat me with a little more respect. I suppose you still want to eat, right?
Wave. I am the wave. The love child of water and wind, sun and moon. I move energy, nutrients, life. I move you. I've captured your imagination since the beginning of time. You honor me. You chase me. I am a symbol of something wild that exists in you. But lately, it's I who feel wild. Choked by your trash, overheated by your pollution. It makes me sick. It makes me lash out. Don't you know I can decimate you? What do you think I can do to your currents, your coastlines, your climate? My requirements are simple. Stop stripping the forests that keep my water clean. Stop filling the atmosphere with dead carbon. And keep your plastic to yourself. Work with me now, before it is too late. I'll keep coming. I am the wave.
Look up. There I am. I am the sky. I am a warm, protective blanket wrapped around everyone on Earth. I can bring clouds, rain, and wind. I can be an ice storm. Without me, you'd fry. Every day, I am the breath you take in. Yet you are making me sick. I am congested, off balance, polluted. You see, I am more delicate than you think. It took millions of years to get it just right. My perfect mix of gases, temperature, and weather that you enjoy. But now your cars, your factories, and dust, they have pushed me past the limit. And you wonder why my typhoons and tornadoes are more intense, more frequent. I have become unpredictable. Less rain here, a lot more rain there. Hotter summers, colder winters. I cannot even control myself anymore. Enough about me. I will show my changing self to you in your days ahead. But in the end, I'll be fine. Give me a few thousand years. I have weathered trauma before. I am not worried for myself. Look up.
And whenever some of them are solved, they add to our knowledge about the universe around us. Are we to solve all its mysteries someday? Time will show.